Hi, I'm Dan Timoney. I'm the project technical lead for two projects within the ONAP platform, the SDN controller, as well as the Common Controller Software Development Kit. In this video, I'll be talking about the SDN controller, which is based on the Open Daylight platform, specifically on Open Daylight Carbon. And it happens to use the Common Controller SDK as libraries, but really I'm talking about the SDN controller in this video. The SDN controller is based on Open Daylight with some notable additions, the most notable being this concept of the service logic interpreter. What is the service logic interpreter? What the service logic interpreter is it's code that allows you to execute directed graphs. What are directed graphs? Well, a directed graph allows you to capture the behavior that you want the controller to implement without having to write it in Java. Not that there's anything wrong with Java, but what's nice about directed graphs is that you can load them in real time. You don't need to go through your traditional compile release cycle. So if you find that, I know this never happens, but if your business people give you a change at the last minute, unlikely as that may seem, you can go make a change in the directed graph, upload it, and boom, your service is working again. The problem that the SDN-C is trying to solve, and generally the problem that SDN controllers in the industry try to solve, is simplifying the process of setting up network connections, which in the past has been very, very labor intensive. You really don't want your folks in your data centers to be sitting there monkeying around with routing tables on a bazillion different routers. The point of an SDN controller is to automate all of that so that you don't have to worry about it. It's less labor intensive, less costly, therefore, less error prone. This slide shows you where SDN-C fits into the ONAP architecture. And you can see it's right down here, along with a number of other controllers. As I said before, it's specifically the network controller. SDN-C consumes some of the common services that you see in the center. Specifically for the Amsterdam release, we'll be using DMAP, and of course CC-SDK, which is the library that makes up a vast majority of the code within the SDN controller platform. So in terms of workflow, messages that come into the SDN-C platform come in through this northbound API interface. The code for this interface is typically generated from Yang models that are provided that define the interface. They're just generated by the Open Daylight Yang tools compiler. And mostly what our northbound API does is it just translates the input that it gets to a format that the service logic interpreter knows how to interpret. Then it hands off control to the service logic interpreter that runs through one or more directed graphs. It might save its state to the Open Daylight config tree, which is the pending view of data. And it might interact with other resource adapters to get to external resources like a SQL database or ANAI, which is a normal thing that we do. We normally save our state in ANAI. And if we need to talk to an external third-party SDN controller, as we will in Amsterdam, we can talk to it, if they talk RESTconf, we talk to it through a RESTconf adapter. If they talk netconf, we would have a netconf adapter here. And eventually, the plan would be that there would no longer be a need for these third-party controllers. We would have adapters that talk directly to the Open Daylight layer.